Bismillahirrahmanirrahim. Assalamu alaikum. So we will continue with our new lecture. In this next module, we shift our focus to a powerful concept that is transforming the whole world of industrial systems. This is the industrial IoT Edge. So edge computing plays a very crucial role in bringing it brings the intelligence. It brings the it brings the intelligence close to your machines, sensors and actuators at the factory floor. And instead of sending every piece of data, the benefit is instead of sending instead of sending every piece of data to cloud. What Edge can do is Edge IoT. What it can do, it can process data. It can also analyze, and even it can act locally. Okay, so the benefit is that it and all of this, it helps us to get some very good benefits. So what are the benefits? For example, we will have faster decision making, and we will have reduced latency, and also we have optimized bandwidth is optimized, or we make use of it optimized, and also it will enhance the what you call security. Okay, and so we don't need to go and send every data uh, to the cloud. So what Edge is doing, and basically Edge is doing, Edge is connecting the industry. It will be talking to industry through industrial protocols. In the middle, we will have Edge, and on the other side, it will be talking to the cloud. Okay, so let's dive into the details. Okay, so in modern industrial systems, especially those built on the industrial Internet of Things, we increasingly see a dual architecture. What I mean by dual is we will have the edge and the cloud. They work together. Okay, so they work together, and the cloud offers very powerful centralized storage and computing capability. So they work together. Okay, so and edge is near right to the next to the machines and processes. We can think about edge as junction point or as a middle layer, and it see we also have the storage in the cloud, but this is bigger storage. But at the edge level, we have store and forward. So this helps us whenever we have this also helps in many things. Okay, and one of them is helps in many ways. Okay, and some of them are, for example, if they want to do some kind of a local analytics. Okay, for local analytics, they may need some historic data, and also it may help when the internet has some issue. Okay, internet for some is down for some reason for some time, so it should be storing the data, which is very important for the cloud. Okay, so and also we see that it is able to talk to the OPC server through the OPC UA and DA model, and on the other side, it is able to talk to the cloud through the MQTT, COAP, and WebSocket protocols. Okay, so the key functionality here that we achieve from the edge is that it is providing us data buffering, It is providing us the data buffering, and it is also doing the local analytics, and it is also ensuring that secure means protocol sort of translation, okay, between sending the data to the cloud. Okay, so this is like a three-step process: one, two, and three, from the factory to the edge and up to the cloud. Okay, so overall, this is helping us to this helps us to realize to realize smart factories, and where we can have very good predictive analytics as and when required. And the good thing is it is scalable. Okay, since it is divided and modular, so it is very it helps us to achieve a scalable IoT solution. Okay, next we will discuss about the need of the IoT edge, why it is important. So the first point is that the data exportation restrictions in many industries, national and laws and regulations and the policies, they don't allow the sensitive data or the high risk data to send outside the. So if you want to send outside data, is money. So outside, no, it is not allowed. Okay, so it is not allowed to send the data out of the company premises or across the border. So edge computing allows us to process and analyze such data locally without violating these constraints. The second point is about the network bandwidth limitations. Not all industrial data is lightweight. For example, if we talk about the vibration data, for example, and taking and recording 1 to 50 kilohertz, 1 kilohertz to 50 kilohertz. So if we try to send this data to the cloud, it will overwhelm the network. Okay, so it will burden the network overall bandwidth it will consume. So instead of sending all the data, the edge device can filter, process, or even compress the data before the transmission. The third thing is about the network latency concerns. In the real-time control in the real-time control systems, delays are dangerous. Okay, so from control point of view, okay, from control point of view, we don't like delays. Delay is not good. Okay, so in real-time control systems, delays can be dangerous. So if the corrective action has to wait for a cloud server response, it may come too late. So edge computing ensures that the time-sensitive decisions are taken care of. For example, shutting the motor or adjusting the valve, they should be taken immediately and locally. Okay. The fourth point is the data connectivity issue. Sometimes the internet access is not available or intermittently. There is problem, especially in the remote or harsh environments. So edge devices allow us to maintain the automation and operations even in the offline scenario. So whenever there is a problem, then the edge device can work offline. Okay. So in summary, edge computing makes IoT more secure. Okay, so what happens is, let me write it here. So overall, the edge computing uh, makes IIoT more secure, efficient, and also reliable. Okay, and especially for for the for industrial setting. Okay. Mm, okay, so now we will talk about the capabilities of uh, to function efficiently in the industrial setup. So the first thing, it must support the OPC client interfaces, both OPC Classic as well as the new modern OPC UA. This allows the edge device to connect to the industrial data sources like PLCs, DCS, and SCADA, and even to the historians, right? The second point the second point is it must have an OPC proxy, meaning it can handle the data requests coming from either OPC Classic or OPC UA. So the proxy helps us to maintain the old and new OPC client data and route and respond to them accordingly. Okay, because both of them they have different type of information model. So this is very important for the legacy and modern system to work together. So this helps us to that the old legacy systems and new systems they work together. Okay, it should be there. So the third thing is about the edge device should enable the bidirectional communication with the cloud. This is another important thing. So this is usually done using the internet based protocols, like for example the MQTT and advanced message queuing protocol and hypertext transfer protocol, secure, enabling. This means that the data can flow to and from the cloud, enabling the all the control or configuration, and this basically helps us to cloud based configuration. Cloud, because the edge devices are many, so we need cloud based configuration, easily done through this all the activity. Okay, and then it should have also the store and forward mechanism we saw in the last slide, because in many real world factory setups, internet connectivity is not always guaranteed or stable. So the edge devices store the data locally and forward it to the cloud once the connection is restored. And there are several reasons, because when there might be a problem with the internet, it's common. The fifth point is about the edge device should support the centralized management. Okay, so this centralized functionality and management from the cloud, it is very important. This includes the remote monitoring and deploying for example, the configuration. This is also important. Sometimes you need to apply the software updates, patches, and some security patches. So all of them without needing to be on site. So this requires that you remotely configure your edge, okay, or update. So these capabilities make any edge device a smart bridge between the factories. So the edge device, before it make edge device before it makes a factory smart, edge itself should be smart enough. Okay, very simple. By following all these points, okay, so that it provides a smart bridge. So it becomes like a smart bridge between industry floor and cloud. Right. Okay, so we continue with the edge capabilities. So it has to be like multi-platform, meaning they must be able to run both on Windows and Linux, both environments. And secondly, it should be flexible and scalable, whether you are working with just a few hundred tags or tens or thousands of tags. So it should be flexible as well as the scalable. The same device should handle the ranges smoothly. So now we have the advanced capabilities that really bring out the power of the edge. For example, supporting common bus protocols, for example, like the Profibus. These are the common bus protocols in the industry, Modbus, Ethernet, IP. So this is essential for integrating with and this reflects the diverse industry equipment. Okay. Now they should be able to capture um, and process high frequency data. Very good, very important. Like for example, the vibration or pressure readings ranging from 1 hertz to 20 hertz, 20 kilohertz, and having having built an analytical engine is a big plus. So if we are able to add analytical engine, this allows the local detection. Okay, so it will allow us the local AI to implement local detection, for example, or any other processing. This is a big plus. Okay, so we can say that this is a big plus for these days. Okay, AI at edge, we can say that. So this allows the local detection of anomalies or real-time event processing without waiting for the cloud. Okay, so this is also important that whatever it does, it do without cloud, waiting for cloud. Okay, waiting for cloud. Okay, so this all is very important, very important point. And then from control perspective, the advanced process control, it should also be able to implement APC. We call it advanced process control, to not just monitor but also to optimize, because advanced process control helps us to optimize the processes on fly. And finally, the security is another concern. So it should be the trusted platform module that can be integrated to secure data and storage and the communication, okay, and all these stuff. So for those, so if you are more interested, you can further explore more on this reference that from where we brought these points. Okay, right. So let's talk about the OPC UA proxy we discussed, which plays a critical role bridging in the industrial communication system. Basically, OPC UA proxy is a component of OPC wrapper, and it acts as a bridge between the classic suite. Okay, so this is uh, classic and the new UA. Okay, so or modern, you can say that modern OPC. Okay, so classic is the old one or classic one or classic OPC. So this makes like a bridge between so the OPC UA proxy is a component of OPC UA wrapper that acts as a bridge between the OPC classic clients. Okay, so like DA, HDA, and the AE and the modern OE UA servers. We see that we have OPC DA, HDA client, or AE, and through the OPC proxy, we are able to connect and share the data with the new OPC world, okay, which is UA, and this is the classic OPC world. Okay. Okay. So now let's move on to IoT. Okay, now let's explore the differences between the IoT Edge and the industrial IoT, the simple IoT Edge and the industrial IoT Edge. Here we have one extra I. So let's see what it is. So the first major distinction is in the data collection. A typical consumer IoT Edge maintains, for example, 10 to 50 data points per piece of equipment. Say a smart fridge, for example, or a washing machine. In contrast, the IoT Edge industry IoT Edge can handle 300 to 330,000 measurement or data points. So, and often it is multiple assets across the production facility. So often from the multiple assets. So that's a massive scale. So from this is tiny data, okay, tiny or small data, and to very large data sets. Okay. This is one. The second thing is industrial systems demand stronger cybersecurity. We need IIoT requires stronger cybersecurity because these systems often are the critical systems, critical control systems, critical infrastructure. So we avoid exposing sensors directly to the internet. That's why we need secure and reliable architecture. So finally, there is a difference between the also the budgeting constraints in the IoT world, adding sensors may cost only like let's say $50. But when you talk about industry, turbine, for example, is for example $1 million. Okay, so you are making an IoT product for to save. Think about like you are making an IoT monitoring for a $50 thing, and you are talking about making some IoT product or service for $1 million, $1 million asset. Okay, so the budgeting and the scalability are more sensitive in IIoT deployment. Okay, so let's now understand the key components of the IoT Edge. What are the components and how it is being standardized? Uh, This basically serves the bridge between the industrial operation and the cloud-based systems, and it has three main components. It has IoT, the edge as a gateway, the edge tools, and then the edge computing. So, in the edge gateway, it is basically your it is the core component responsible for forwarding the data to the from the industry to the floor to the cloud and premises. So it's essentially the main communication bridge. Okay, so this is the main. We can say that this is the main communication bridge for the edge. Then comes the second tool, which is edge tools. These are utilities. Okay, so these are simple utilities which are used to configure or log management or applying some system updates or patching the operating systems. They help maintain basically. It is like maintain. They actually maintain. They help maintain or troubleshoot the edge environment locally and remotely. Okay, so we should be able to do it both way. Finally, the third one is the computing. This is by the way, this is like this is the new and more powerful, more desired, uh, powerful, and we are looking into applying the AI capabilities to it, agentic AI or AI capabilities, basically AI capabilities on edge. So that allows the local data processing at the site level. It can trigger the immediate actions based on the analytics and send insights directly to the central system without waiting. Okay, this is the important thing. Without waiting for cloud. Okay. So cloud may come into play its role, but it still do its job without waiting for the cloud. So these are the three components together make the and these three components together they make the edge intelligent, intelligent, and also responsive and also secure. Okay, so it makes it intelligent, responsive, as well as secure. Okay, yeah, this is interesting. This slide gives us a sort of a visual representation of the different components of and IoT Edge. On the left side, what we see is a data source, sensors and controllers. Okay, uh, sensors and controllers are connected through the field bus, and these are the core devices. And on with the OPC interface, for sure, this is the OPC interface. This all these raw data, raw industrial data, enters the we see that it enters the device core. Okay, so this all data enters the device core here. And the edge gateway handles the protocol adaptation. So there is a IoT uh, this IoT gateway, and this we have like adapter. Sorry, it okay, yeah, okay. So we have the IoT adapter here. Um, the edge gateway is basically handling the protocol through this industrial adapter and IoT adapter, and then forwards the data towards the cloud through the IoT adapter. Okay, and the store and forward mechanism ensures that the data is not lost during the network interruption. So we are saving here, okay, and buffering the data until the connectivity is restored. Higher up in this stack, we see that we see the edge computing functions. Like, for example, we have the edge analytics here. We have actions. We have some custom modules that you may develop for local for any of the local processing. This is, you see, this is all in local processing. From the IoT gateway, the data is managed, and then it comes to the computing, where it may have different parts. Then it comes to the edge tool. Edge tool layer is basically providing like important what you call the utilities. Okay, so this is providing us the utilities. For example, we have the cybersecurity and patching module. We have the functionality of the auditing the logs, configuration management. We also have auto registration. So, and then on this side, we have on the right side here, this one, device manager. So the data flows outward to the IoT data hub and the IoT data hub and the device manager. Why it is coming here? Because the main purpose is now it is going to be ready for the cloud integration. Okay, so cloud integration and also the remote monitoring is done at this layer. So this modular architecture helps achieve secure, um, reliable, real-time, and scalable processing in industrial environment. Okay, so now we will discuss about the first key component of the IoT Edge in detail. This is the Edge Gateway. So the Edge Gateway acts as the central hub of the Edge device. Its main responsibility of the primary role is to gather the data from the industrial sources like PLCs or the controllers and forward this data to the IoT data hub using the protocols like MQTT, COAP, HTTPS, and AMQP. So it interfaces with the industrial system via OPC or other field device protocols like Modbus, uh, Profinet, and Ethernet in Ethernet IP. So inside the edge gateway, there are actually two major components, and one is the industrial adapter. And this industrial adapter basically subscribes to the industrial field data and publishes it to our data bus. So it acts as a connector to the devices on the factory floor. The the second is the IoT adapter, then takes this data from the data bus and sends it towards uh, the cloud or the data hub using the internet protocol. So this modular design allows real-time data flow from sensors to the cloud analytics while maintaining the flexibility and protocol independence. So this is the main aim of the gate edge. Um, So another essential function within the gate edge gate is the store and forward component. So this mechanism provides a temporary storage buffer that holds the collected data locally whenever there is a network disruption. So it ensures that the data is not lost due to unstable or any network in proper in a connectivity problem. So this becomes especially important when the data is transferred through the wide area network rather than the local area network. Since in WAN we have higher latency and instability. Okay, so depending on the design, the store and forward mechanism may provide interesting mechanism. For example, a small buffer to handle the brief disconnections, and or the large disk-based storage to deal with the prolonged downtimes. Okay, so depending upon what type of downtimes we may face, we can come up with a small limited buffer, or we can go for a large disk-based storage to deal with the downtime or even the high volumes of data. So this ensures the reliability and resilience of the IoT data pipelines. Okay, um, so this is store and component is basically increases the reliability and the resilience of the IIoT data pipeline, even uh, even under adverse network conditions. Okay, so this is an important aspect. Uh, then the second core component is the edge computing. The edge computing actually refers to the local execution of the analytics directly at the edge device. These analytics are responsible for different functions, for example, filtering, aggregating, or detecting some kind of anomalies in real time close to the data where it is generated. So a key aspect is that these analytics are remotely deployed through the edge manager, and there are now very interesting and good services through which you can do and smartly manage your IoT devices, so which operates basically from the cloud. All these edge managers, so the edge manager does not just deploy the updates, it can also control the behavior of your edge device. So for example, starting or stopping the analytics, um, and also requesting, for example, a snapshot of some high frequency data uh, to be sent to the cloud for further analysis. So again, this enables the intelligence. Okay, so this computing, the edge computing enables number one, intelligence, and also the dynamic control based on like a remote decision making. Okay, so let's now discuss the third component, the Edge tools. Edge tools basically is a combination suite of utilities. Okay, this is a suite of utilities designed to help manage the edge environment efficiently, and they play a key role in simplifying the configuration, monitoring, and maintenance tasks. So these tools should offer a user-friendly interface that enables operators or the engineers to configure, analyze logs, and manage the security patching, for example, and configure different kind of adapters. And moreover, the edge tools often collectively they collaborate with the edge manager, because they have to collaborate with the edge manager, especially for the tasks like renewing the like some kind of like digital certificates, for example, and managing the authorizations or even self-registering the device through the initial setup. So in short, these edge tools basically they help ensure that the edge is not only smart and connected, but also manageable and secure. Okay, so if you have something, so it should be also be manageable. Okay, now let's talk about some implementation tools for deploying the edge solutions in IIoT environment. So we will go through some of the uh, mm, possible solutions. Cloud vendors and OEMs are deploying these days a range of solutions, and every day we are having new tools available on daily basis. Okay, we will go through some of them, and most of them are like cloud. Some of them are through the operating systems or through the cloud agnostic SDKs that support the edge deployment. So one of them, the mostly used is one of them, the Azure IoT Edge, which is Microsoft like Edge solution. It is store and it what it supports your store and forward mechanism and edge analytics, and also several protocols it is supporting to translate the industrial protocols to the cloud ready formats. And importantly, the Azure IoT Edge also supports the OPC server, and in both the classic and OPC US. So this is very important aspect that we were discussing a few slides ago. On the other side, we have the green grass, AWS green grass, and this is Amazon's answer to the edge computing. It lets you build and deploy the edge solutions using the AWS SDK, and it allows your local analytics, local actions, local action processing, and it also gives us the cloud-based management and analytics. Permanent data storage is another aspect. So one thing we should note is that the green grass supports the OPC UA, but does not support the OPC Classic. Okay, so this may be a consideration for the legacy concern for the legacy systems. Okay, so this is an important point. We have to be careful while Azure is supporting both. The AWS does not support the classic interface. Okay, now continuing with the edge implementation tools, we now explore some open and cloud agnostic, open and cloud agnostic solutions. Okay, so top of them is one of the Android IoT. It is supported by Google. It offers an SDK for edge development and promotes the Android as a viable next generation platform for edge devices. Then we also tried the Node-RED. This is a lightweight and visual programming framework, ideal for quick deployment for IoT and edge solutions. We did some of examples from this. It supports the platform like Raspberry Pi and Node.js. And Node.js is not designed specifically for the industrial environment, but it works great for your concept or pilot designs. Okay, it is very good for them. And prototypes, and you can and it integrates with the other components. Okay. Then we have Docker Edge. It is more enterprise focused, and it's collaboration between basically the General Electric and Docker. It is tailored for IoT predicts platform, and it brings some sort of container-based solution, container-based architecture to the edge, making container-based solution or architecture, okay, to edge. So this allows a sort of container-based architecture to the edge, and this helps us to implement like in a deployment is good. Okay, so modular and scalable. So this is helpful for modular and scalable. Finally, we have an Intel IoT Gateway. It is a cloud agnostic solution by Intel, and it is designed to integrate the industrial system secure with the cloud using the Intel's hardware and the software. Next is this is the last slide in this video. The fog. In this slide, we contrast the fog computing. What is the difference between fog and the IoT computing? Let's go through this. Cisco defines fog computing as a highly virtualized platform that provides compute, storage, and networking services between the end devices and the traditional computing device centers, typically, but not exclusively, located at the edge of the network. This is how the Cisco defines the fog computing. And the primary benefit shared by both paradigms is the ability to store and process data locally, enabling real-time applications. And improving the efficiency. This is very important to improve the efficiency for the business operations. And for fog computing, however, it follows a hierarchical architecture. So this is the benefit of the edge computing. And next, the fog computing, it follows a hierarchical architecture. And in hierarchy, it is basically like a three-tier architecture, three-tier solution. And what happens here is and the interesting thing for this the edge computing and the fog computing is that the fog computing may exist between the edge and the cloud. So fog computing is related to some kind of like a distributed nature, and it may exist between edge, pure edge, and cloud. While the edge computing is specifically handled at the edge side. Okay. So for further, and that's why we say that fog is not necessarily very close to the edge. Okay. It may be distributed. For further reading, you can check this reference. Okay, so we will end this slide here, and next lecture will be on the edge deployment and some scenarios. Thank you very much.